Okay, so let's look at how we solve for average atomic mass. Like I was saying, we can't just take the mass number or the actual measured weight and add them up and then divide by 2. We don't do that. We base it off of its relative abundance. Relative abundance means that that is the percentage that we find that specific isotope on Earth or in the universe. So when we take our mass number and we multiply it by its relative abundance, which it's most of the time given in a percentage form, we have to change it and convert it to its decimal form. So when we are using relative abundance in our mathematical manipulations, it must be converted into decimal form. So let's kind of review real quick how we do that. So for instance, isotope of chlorine-35 said that it was found 75.77% of the time. So what a percentage means is you were taking that number out of 100% or 100 things. So that means you take the number 75.77 and you divide it by 100 because that is, you're taking it out of 100. So when you plug that in the calculator, that's going to give you the decimal of 0.7577. Okay, so whenever you get a percentage, you just divide it by 100, and that will give you the decimal form. The other way you can do this, which is more simplified, is whatever your percentage is, you just move the decimal 2 places. So for 90%, I would take the decimal there and I would move it 2 places. So the decimal form of 90% is 0.90. Okay, so that has to occur before you actually plug in to solve for average atomic mass. So what we did to figure this out is you would take the weight of the isotope. So sometimes they'll just give you the rounded whole number, and other times they'll actually go into the lab and give you actual lab data where you have, it would be 35.00123. They might have actually physically measured the nucleus of that atom. Okay, so just use whatever number they give you in the problem, and you're going to multiply it by its relative abundance and add it to any other isotopes that there are. That's how we find the weighted average. So what they did here, and I know it's worked out on the slide, but I'm just going to kind of jot it down here, is they took the weight of chlorine-35 and they multiplied it by its abundance in its decimal form. And then they're going to add it to the other isotope that is found, and that's chlorine-37. So that's its mass that they gave us. And then the relative abundance of that isotope in decimal form. Then you plug it in a calculator and it gives you the average atomic mass of that element. Now, what you should be able to do is self-check yourself. Whenever you're figuring out these problems, you should be able to take your answer and compare it to that on the periodic table. Those numbers should be identical or extremely, extremely close. So this one's off just a little bit, and that's because we use rounded numbers instead of actual numbers.